Welcome back to the series of Ekalavya EC Lab experiments. I'm Vinay Kumar from Vidya Technologies. In this episode, let us do the demonstration of the motor capabilities such as servo motor, DC motor, and stepper motor. The DC motor and stepper motor will demonstrate that in the subsequent episode. In this particular video, we'll see with respect to the servo motor the angular rotation, so the angular control of the servo motor, okay, using our Pocket HDL platform, that is Ecolab development board. So in this video, let us review the code. Let us try to understand the code, and uh, you know, let us also go through the circuit which I've used. I'll show you the rigged circuit too, and let's try to map with the circuit that I've shown. After that, let's program the design onto the Govan ADA tool onto the Ecolab development board and try to verify the functionality of the written design, right? So I guess that's it. Let's get started, guys. So this is the code itself. So this has multiple, many input output pins which access some other modules too, like HDMI camera, which might see a bit overwhelming, but among these we are using only a few pins. That is IO1 for this particular uh, you know experiment. We are going to use reset, yeah, URTX and RX. Then we're going to use FPGA clock. So that's it over here. Okay, before code, I'll just show you the circuit diagram. So this is the circuit diagram for this particular project. So the PC, that is a system which has a Govan area tool and the Ekalavya board itself, and the motor driver and the servo motor are the modules that we're gonna need here. And let us not forget the power supply or the battery, whichever is convenient for you. So here Ekalavya board will be talking with the system uh, with using UART protocol. Okay, so this UART protocol, we are using this USB to TTL module over here. So the RX of the uh, you know the PC will be connected to the 125th pin, that is TX, that is UART TX, and the TX of PC will be connected to the RX, UART RX, that is 124th pin of Ekalavya development board. Okay, so using USB module, USB to TTL module, will be communicating with the PC. Okay, so there's one more pin, that is IO1, which is 126th pin. So using this 126th pin, we'll give the inputs to the motor driver. So after processing it, the output of the output will be sent to the signal of the servo motor. Servo motor has three pins, that is signal, power and ground, where signal will be received from the motor driver, and 5 volt will be connected to the 5 volt power supply, and ground will be connected to the negative of the power supply, right? So we're going to connect this motor driver also with the 5 volt power supply, right? So this is the circuit diagram over here. So yeah, let's now move on to the code. Here, as I said, we are using IO1 and UARTX, UARTRX, then the clock. Okay, so the FPGA clock, in order to drive the clock, we are using IP. Okay, so that is a oscillator of 40 megahertz will be taking it, and the 40 megahertz will be given to the PLL in order to break down the 40 megahertz into the desired frequency that we're gonna need. Okay, so that is the two IPs that we'll be using over here. After that, we don't need this for this program. um, so these are the wires and registers for intermediate communication, or storing of the data. So yeah. mm, mm, mm. This is the UART and UARTX and UARTRX module. So here is the module that I have written over here, and this is the top module. Okay, we'll be calling the function modules over here. So we're going to use you're having clock enable sorry, byte to then if this communication bus is active or not, and this is the transmission taking place. That is okay, this is the UART TX that we're going to receive the data from, and if the communication is done or not, that will be indicated by this. Similarly, here in the RX, we will be using clock and the serial communication, where we'll be receiving the data, and DV is used for done. To indicate the status of the communication is been done or not, and byte that's for the intermediate operation of the UART communication. Again, these are various intermediate reds or wires to sustain the communication thing. So here we are sending the command as I showed you on the circuit diagram. We are gonna send a few of the commands which will be instantiating the address and the data that needs to be processed by the Calavia board, and sending it to the motor in order to set the frequency and to set the or to give the data. Okay, so that is here. I'll explain the command. So the command will be like this. Okay, this is the command. So first comes the header, second comes the W or R, then is this colon, and XX is the address, comma is the separator, and again XXX is the data, and again slash n is the we are using colon in order to terminate and you know give the acknowledgement of the command if it is received or not. So I'll just explain this. So if it reads the hash, that is header, then it knows that the communication has been initiated. Then after that it will be in lookout for W or R. So if it is W, then we can write the command address all. If it is read, it will be sending the data and we'll be reading the communication part. Okay, so that is it. After that it will look out for the limiter which so okay, this is the delimiter that separates the header and the read write type with the no address and the data. So this is the first separator over here. Okay, after that we'll be having this XX, that is nothing but the address, which is of 16 bits. Okay, so after that again there's a limiter, that is separator between the address and the data. Okay, so after that we'll be having the data itself, which is again of 16 bits. Then at the last we're gonna terminate the command. Okay, so here we're gonna use we will be having a colon if the command is been acknowledged, or an asterisk if it is not acknowledged. Okay, so this will be the sequence of the command that will be sending from the PC to the development board. Okay, so in order to access the servo motor. So okay, so these are the state machine that we're using for passing this particular command onto the servo motor in order to make them work. Okay, so each passing states have been assigned with values, and this is used for the smoother operation of the program. Okay, so here we are using a 20 megahertz. So this is the output of the PLL. Okay, so we'll be using 20 megahertz for this particular operation. Um, then then it starts. Okay, if it is reset, if the reset is triggered, then the state machine will be in idle, and the header wait for header will be running. The timer will be of 0, and the read write command will also be of 0. So if it is not reset and if the clock is been running, then the case starts. So here the actual operation starts for this particular experiment. Okay, so here the passing state, the passing state begins with the parsing idle. So idle means uh, it will be look out for the header. Okay, so here 1 byte if rx done, then data is received from passing state to next step. Just this. Okay, I'll just simply tell you. Okay, fine. So when state machine is on the idle, it would be on lookout for the header. As I said, the header part is this the hash. So if the hash has been detected, then it will it will wait for the command, next command, that is W or R. Okay, so until we read the R, we have set a timer that will be counting. Okay, so if within the timer it reaches 0, if the no the subsequent command is not received, that is in this case the W or R, if it is not read, then it will send an not acknowledged, or it will send a not acknowledged, that is asterisk in this program, and it terminates the sequence. Again, it has to start from the beginning. Okay, so this is the header. After that, it will read for W or R. Then after that, within the given time, it has to read the limiter. So as I said, W means it. We will be having the liberty to write the command and add the address. If it is R means we'll be having the liberty to only to read the data. So R, we are gonna use it in the I2C. Here only we're gonna use W. Okay. So in this particular video, we'll just see W. Okay. So first we'll read header, then we'll read W, then after that we are waiting for the delimiter. So this delimiter, as I said, it will be a separator between the header right and the adder. So after this, again the timer starts. Within the given timer, we have to read the um, address. So this block is of address. Address is of, as I said, 16-bit. This reads the upper 4 bits, and this reads the lower 8 bits. I'm sorry, I told here it's 4, it's 8 bits. Sorry, yeah, bits. And here also that is MSB and LSB. So after this, it will be looking out for the delimiter, which is a separator, which separates address from the um, data. Okay. Right. So here address means we are trying to interface this with, actually, as I told, we are trying to have inclusion of multiple modules in this particular program. So if it is of, if the address is read as 00, then we'll be using the LEDs. If it is of 01, uh, then we'll be using the what is it? Okay, first is LCD, that is 00. If it is 01, then it's I to C. Then um, we are also trying to interface, access the SPI, and we are also trying to access the motor driver. Okay, so here the command address, if the correct sequence is given, then only the motor part will be getting accessed, else different modules or protocols like I2C or SPI will be accessed. Okay, after that we are gonna be looking out for a separator between the address and the data, and then we'll be looking out for the data. In our case, the servo motor, the data that it's going to read will be controlling the angle of the servo motor, right? So so that is accessed over here, and after that Yeah, after that it will be looking for the acknowledgement. If it is acknowledged, then we'll be getting a semicolon. If it is not, then we'll be receiving as a star asterisk. So this is the sequence that we are going to use in this particular uh, experiment. So these are of different modules to you know interface. So that is how the flow of the program goes. Let me try and compile it. So it's almost done. Okay, now the compilation and synthesis has been done. Let us state. Okay, there's still CST file. So CST file, whatever the pins here on the Ekalavya board I have initiated here. So be it LED or IO pins or HDMI UART, camera, everything I have initiated over here. So that is it. This is the IP block. Okay, this is PLL IP block, right? This is the UART RX. It's again, it goes with respect to protocol. Fine. This is the TX. Okay, this I'll explain it. Okay, geo file, you don't need it. So let me open the camera. I know this is a bit mess. So I'll just tell you, I'll just guide you here. So this is the Ekalavya board that is being connected via, you know, this is the USB to this. This is the USB to TTL module that I've connected the Ekalavya here. The RX and TX of the Ekalavya board is connected to the TTL module, and this TTL module is being connected to the PC. Fine. So that is used for the communication between the PC and the Ekalavya. So here, this is the 26th pin, 126th pin. That is whatever we are gonna get the commands using this UART RX and TX. This is the IO1, and that will be sent to the input of the motor driver. Okay. I don't know if you guys can follow. Let me just quickly open the. System is become slow. So okay, here this 126 pin is connected to the motor driver input. So this is the 126 pin, that is the IO one that is connected to here, and that is in turn connected to the input of the motor driver, right? So here the motor driver output is being connected to the uh, signal of the servo motor, and this is the power, um, that is 5 volt, and this is the ground. I have connected the ground from Ekalavya 2, and this is the ground from the power supply. Here is the power supply. I don't know how shall I show it. So this is the power supply, okay. So here uh, I've connected this to 5 volts, which is of 2 ampere, 2 ampere, okay. So that is connected over here, and that 5 volts is being connected to the servo motor, and as well as the motor driver over here, okay. So I've rigged up the circuit. I've rigged up the circuit according to the circuit that I already shown. Now let us try to uh, program our Ekalavya. I don't know why my system has become too slow. Maybe because I've opened too many browsers, applications. Yaar. Okay, finally. Okay, the Ekalavya board has been programmed. Let me open this. Is the Hercules setup, which I'll be using for in order to communicate. Uh, so first line is to write the you know set the frequency. This is the command, so data command, okay. So now let me send in the uh, let me set up this frequency by sending this EFB. He's calculated to 50 hertz, okay. So this works on the 50 hertz frequency. Therefore EFB, according to the calculation here, is correlated to 50 hertz. So as I said, this is the sequence that will be first the header, and then the read write type, then the delimiter. Okay, so again this particular thing is the address, and this is the data part, and if it is acknowledged we'll be getting a semicolon. If we don't get, if we don't send a proper command, then we'll be reading here, and no, if since the command is wrong and it is not acknowledging, I'll be getting the asterisk symbol over here, right? So I've set the frequency over here. Let us you know try to access our servo motor. So here, this is here, let me okay, send the code. So that is being done. Okay, now it has come to the 0 or the origin position over here. Now let me give the extreme right command. So okay, we can edit how we want VF. So that is extreme side of this. All right, I'll show you also. Okay guys, so this is how the we send the command in order to